Good morning, class. Um, Today we're going to be talking about where does the Earth's internal energy come from. Before we do that, we're going to do a little bit of a vocabulary review for on the geosphere, what the geosphere is.
Okay.
Uh, so with that in mind, we're going to get going here. So key vocabulary and ideas. First is the geosphere. So the geosphere is basically made up of a prefix and a suffix. Geo basically comes from ancient Greek, meaning earth, usually in the sense of like land or ground. The suffix sphere, it's not as in like a three-dimensional shape as you might consider, like the earth is a sphere, but it comes from the third of three definitions. It basically means a zone, a layer, or a region enveloping or radiating from earth or another celestial body. Um, so basically, the geosphere basically refers to layers that make up the planet, in this case, the Earth. The Earth's geosphere consists of a solid inner core, a liquid outer core, mantle, and the crust. Now, when we think of geo, you're going to hear that word a lot in earth science. For example, geology. Uh, Logia means means study of in Greek, so it's going to be the study of Earth. Geography is drawing, writing, recording, or describing. That's the graphy part of it. So geo is land, and graphy is drawing, writing, or recording. So geography is going to be basically your drawing or writing or recording or describing the land. And then you might recall from middle school, if you did any weather, you may have heard of geosynchronous satellites, or maybe even from the Weather Channel or your local weather. Um, Weather satellites have an orbit that is in sync with the Earth's orbit, so it's always in the same, going to be in the same location. And then the other part of that is sphere. We're going to be hearing a lot of different types of spheres when we're talking about the geosphere. We've got the asthenosphere, which basically astheno comes from the Greek word meaning weak. It's the weak zone sphere of the upper mantle. And it's right here in this picture. The lithosphere, again, litho is derived from the word stone in Greek, and it literally means the zone of stone. So that's the lithosphere is the Earth's crust and the asthenosphere, and it's where we live, and it's basically the continental crust and then also the ocean floor crust. And then the mesosphere, mesos in Greek means middle, so it's the middle zone of the Earth's interior. And then obviously the one that we always hear about, which is another sphere that we talk about in Earth, it's the atmosphere. So in ancient Greek, atmos means gas or vapor, so it's the gas zone. Uh, so now we're going to be moving on to thermal convection and thermal convection inside of the geosphere. So thermal basically relates to heat, and convection is movement within a fluid or gas with less dense hot fluids that rise, and then denser fluids that sink. So you may have gone over this again in middle school, where you see hot air rises, cold air sinks, uh, that type of thing. Or even better, in an example of a boiling pot of water, you've got the heat being applied at the bottom of the pot, and then that heat rises up. The water that's heated rises up, and the cooler water that was at the top then starts to sink down. And that's how it works basically inside of Earth's mantle as well. And I have a couple of GIFs here that we can take a look at. This first one, you'll see the yellow area is hot magma flowing up, and then the blue areas are at the top of the mantle, and you can see it's cooler, and then it starts coming back down in that GIF. Uh, Now going back to the other GIF that I have, and you'll see right here and it kind of explains itself. You could see the convection. And then at the end of this one, it also shows us our seafloor spreading. And that's going to be something that we are talking about after we do our group activity. But before we get into seafloor spreading, basically what we're going to be talking about, so where does this heat come from that's causing all this thermal convection in the earth? So I want you to get into your lab groups, your pair groups, so just the two of you, and spend about 10 minutes brainstorming on what process provides the endless supply of energy in the Earth's core and mantle. Then we'll get back together in a class and we'll discuss what everyone thought their ideas were. And then we'll go on and we'll learn what that process is. And eventually in this unit, we'll study how it relates to continental drift, seafloor spreading, and plate tectonics. So go ahead and get into your brainstorming groups and we'll meet back in 10 minutes.